हेलो गाइस, अ वेरी वेरी गुड इवनिंग टू ऑल ऑफ यू। कैसे हैं आप लोग? बताएंगे एक बार, ऑडियो वीडियो इज क्लियर? हेलो गाइस, अ वेरी वेरी यस, मेरे एंड पे तो क्लियर है। व्हाट अबाउट यू पीपल? यस, क्लियर। ओके, वंडरफुल वंडरफुल वंडरफुल। प्रशांत तिवारी, कैसे हो आप? अ वेरी वेरी गुड इवनिंग। नमस्ते नमस्ते गाइस। तो एज मैनी ऑफ यू नो, we just completed our thermodynamics basic thermodynamic course on the plus platform last month, and from the next month June onwards we will be starting the second part of thermodynamics, that is solution thermodynamics plus advanced thermo. You can say little bit of advanced thermo as per your gates and PSU syllabus. Okay, so I was just having a conversation with some of you, and I realized you guys really in a need of revision, a proper revision. So that is our title, कि हम थर्मो का रिवीजन करेंगे, बेसिक थर्मो का, बिफोर वी स्टार्ट आवर सॉल्यूशन थर्मोडायनेमिक्स। ओके, आई एम डूइंग ग्रेट, थैंक यू। श्रीकांत, अरे वाह, क्या बात है! श्रीकांत का जोन, हम मिस कर रहे थे आपका जोन थर्मो के बाद। सो तब तक और भी लोग स्टार्ट कर रहे हैं। आप अपने फ्रेंड्स या जो आपके नोन में पीपल हैं जो थर्मो कर चुके हैं और सॉल्यूशन थर्मो का वेट कर रहे थे, आप उन्हें शेयर लिंक सेशन शेयर कर सकते हो। और मैं आप तब तक 2 मिनट में आप लोगों को या आप न्यू स्टूडेंट्स को या आपके फ्रेंड्स जूनियर्स के लिए एक इंफॉर्मेशन पास कर देता हूँ बिफोर वी स्टार्ट। तो अनअकैडमी पे एक ऑफर चल रहा है, विच इज गोइंग टू एंड टुमारो। In 8999, they will get the subscribe. They can subscribe for the GATE and PSU preparation. Okay. They can use my educator code ACE009 for 60% off. Apart from that, जो गेट 25 के टॉपर्स थे उन्हें स्पेशल डिस्काउंट मिल रहा है to do a better job of rank improvement thing in gate 26 if they want to prepare with us again. और बाकी हमारे बैचेस चल ही रहे हैं, लाइक मेनी ऑफ यू आर प्रिपेयरिंग फॉर एयरपोर्ट अथॉरिटी ऑफ इंडिया एटीसी बैच, एटीसी पोस्ट, उसके भी बैचेस चल रहे हैं एज यू कैन सी। ओके, गेट एंड पीएसयू के लिए 28 मई से एक न्यू बैच स्टार्ट हो रहा है जो आज ही स्टार्ट हुआ है। इसमें फर्स्ट सब्जेक्ट एमओ है बाय पुनिया सर, एंड यू कैन सी दिस इज आवर टीम: अंकुर बंसल सर, देवेंद्र पुनिया सर, मनीष सर, दिस इज मी इन रेड सर्कल, अमन सर एंड गुरुपाल सर। तो दैट इज द थिंग। एंड अब आपको प्लस लेना है या आइकॉनिक लेना है, कितने मंथ का प्लान बेटर है या नहीं, वो सब जानने के लिए आप टेलीग्राम लिंक ज्वाइन कर सकते हो, और अदरवाइज यू कैन व्हाट्सएप मी and discuss before taking the plan, before subscribing. Okay, तो स्टार्ट करते हैं हमारा डिस्कशन आज, थर्मोडायनेमिक्स रिवीजन। और यहाँ पे हम बेसिक थर्मो का रिवीजन करेंगे। जो भी टॉपिक्स हमने अपने प्लस वाले कोर्स में कंप्लीट किए थे वो सभी टॉपिक्स यहाँ पे मैंने इंक्लूड कर दिए हैं, एज यू कैन सी। बेसिक फंडामेंटल थर्मोडायनेमिक सिस्टम, फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, थर्मोडायनेमिक प्रोसेसेस, स्टडी फ्लो एनर्जी इक्वेशन, सेकंड लॉ ऑफ थर्मोडायनेमिक्स, हीट इंजन कार्नोट साइकिल, क्लॉसेस एंड इक्वालिटीज, एंट्रोपी, एंट्रोपी प्रिंसिपल, थर्मोडायनेमिक रिलेशंस। थर्मोडायनेमिक रिलेशंस में हमारे जो सब टॉपिक हैं, लाइक थर्मोडायनेमिक प्रॉपर्टी रिलेशन, मैक्सवेल रिलेशन, टीडीएस इक्वेशन एंड पीवीटी प्रॉपर्टीज। तो ऑल दीज थिंग्स वी आर गोइंग टू डिस्कस। ठीक है, तो आप में से जो भी लोग थर्मो कर रहे थे या कर रहे हैं या कर चुके हैं, आपका एक अच्छा रिवीजन हो जाएगा, एंड देन विद द हेल्प ऑफ दिस रिवीजन इट विल बी इजी फॉर अस to start the second part of thermodynamics. Okay, so if you guys are ready, shall we start? Are you ready? सॉल्यूशन थर्मो हम नेक्स्ट मंथ जून में स्टार्ट कर रहे हैं. आप लोगों ने बोला था 1 महीने के बाद करने के लिए, जब हमने वोटिंग की थी. तो 1 महीने बाद अब जून में हम स्टार्ट कर देंगे. डेट अभी फाइन कंफर्म नहीं है. वो जैसे ही टीम से डेट फाइनल होगी आपको पता चल जाएगा. ओके, so are you guys ready for a quick thermodynamic recap and revision? And don't worry, we will also do some good practice questions in this series ताकि आपका एक proper revision हो, and also some of the PYQs. बट ज्यादा बड़ा नहीं खींचेंगे. ये सीरीज जो है हमारी 4 से 5 सेशन में हम इसे कंक्लूड कर देंगे. ठीक है, मैं आपको आइडिया भी दे देता हूँ. This series, thermodynamic revision series, we will conclude in 4 to 5 sessions at max. ठीक है, 1.5 आवर से लेके 2 आवर के हमारे 4 से 5 सेशंस होंगे. 2 sessions will be on the YouTube and 3 sessions on the Unacademy special platform. So to get the link of and access information notification about all the sessions, you can join the Telegram channel. Link you can find in the description, or otherwise you can find it on the other groups also. ठीक है, तो 1.5 आवर से 2 आवर के हमारे 4 से 5 सेशन रहेंगे. टाइम यही रहेगा 9 PM डेली फ्रॉम टुडे onwards. 2 session on YouTube and 3 on Unacademy special. That's how we will do the things, and we will complete our revision series. Okay, so are you ready, everyone? Yes, yes. Then, okay, wonderful. Let's go for the revision. As I have told you, in this series, we are going to cover all these topics along with some good conceptual practice questions, plus some of the PYQs. Not all, but some of the PYQs. You can understand. Otherwise, it will become difficult to wrap up the entire syllabus in 5 sessions. Okay, so let's start today from the basic fundamentals. बाकी आप लोगों में आप जो भी इंटरव्यूज वगैरह की प्रिपरेशन कर रहे हैं, लाइक बार्क एनपीसीआईएल एंड ऑल, आप लोगों को भी ये सेशन हेल्पफुल होंगे, because you will be able to have a proper revision and idea about the syllabus, quick recap, and you can discuss your doubts also in the live chat or the comment box. ठीक है, और जो गेट और पीएसयू की प्रिपरेशन कर रहे हैं उनके लिए तो है ही. तो बेसिक फंडामेंटल्स, तो यू नो, फर्स्ट थिंग फर्स्ट, thermodynamics. So as you guys know, thermodynamics we can split in two parts. One is thermo, one is dynamics. Thermo is related to thermal form of energy. Dynamics, you know, is related to force. And force means mechanical form of energy. Okay. And you know, thermal energy means heat. Mechanical energy means work. So what is thermodynamics? Thermodynamics is the study of interaction between heat and work in a thermodynamic system. In short, I have written like this: thermodynamic system with the help of thermodynamic properties under thermodynamic constraints. Thermodynamic constraints से हमारा क्या मतलब है? You know, laws of thermodynamics. So Any, can you tell me how many laws of thermodynamics are there? Try to be active on the chat. It will be fun. Three. यही तो मिस्टेक हम हर बार करते हैं। थर्ड लॉ ऑफ थर्मोडायनेमिक्स है तो हम कहते हैं तीन है। हाउ मेनी लॉज ऑफ थर्मोडायनेमिक्स आर देयर? मुझे पता है जीरो की कोई वैल्यू नहीं होती, पर आप जीरोथ लॉ को तो भूल नहीं सकते ना। कैसे भूल सकते हो? हाउ कैन यू फॉरगेट अबाउट दिस? So how many laws are there? Four. Clear now? कमाल करते हो आप लोग भी, हैं? कमाल करते हो बस। Now, what is universe? You know, everything we can see, everything we can see or not cannot see. We can feel or cannot feel. That is universe. And system is the part of universe containing matter under observation, under analysis, under investigation. जो भी proverb आप use करना चाहो कर सकते हो. That is system. Okay. And everything else, apart from system, everything else in the universe will be the surrounding. Okay. Like for example, if I want to study this cup, I want to do the analysis of this heat and work interaction here. So this is my system, and everything else in this universe, including this laptop, screen, walls, trees, planets, other stuff, other galaxies are the surroundings. So the surroundings which are in direct contact with the system, they are called immediate surroundings. And the surroundings which are at distant distance away, they are the distinct surroundings. करेक्ट? अब इसमें आगे बढ़ते हैं। और जब हम बात करते हैं थर्मोडायनेमिक सिस्टम्स की, तो thermodynamic system, there are three type of thermodynamic systems: open systems, closed system, and isolated system. and you have the basic idea. Open system are those in which mass transfer takes place between system and surrounding, and energy transfer also takes place in terms of heat or work. Okay, no other energy, only heat and work. Closed systems are those in which only heat and work or energy transfer occur. Isolated, no mass transfer, no heat transfer. ओके, दीज आर योर सिस्टम्स. अब इसे अगर अच्छे से समझना है क्या होता है क्या नहीं होता, तो वो जानने के लिए एक एग्जांपल लेते हैं. तो सपोज फर्स्ट आई एम टॉकिंग अबाउट अ क्लोज सिस्टम. तो सपोज वी हैव अ पिस्टन एंड सिलेंडर असेंबली. Suppose this is a cylinder and here we have a piston. And in this system, suppose we have some gas. ठीक है. अब यहाँ पे एक और टर्म आता है जो मैंने अभी एक्सप्लेन नहीं किया, दैट इज सिस्टम बाउंड्रीज. System boundaries means the separation boundary between system and surroundings, or you can say the surface usually. For example, this is my sum of the system, let's say. So here the boundary which will separate this system from its surroundings is what we call system boundaries. Like these pink dotted lines you can see. That's how we represent the system boundaries. Here I have drawn the boundaries outside the system. So I can say these are my exterior system boundaries or outer system boundaries. Correct? Similarly, suppose if I draw the system boundaries inside the system, मतलब system की surface include नहीं है. So in that case, this is what we call interior system boundaries. Or internal system boundaries. How to prepare for faculty position? कौन से एग्जाम की कौन से मतलब किस सब्जेक्ट की फैकल्टी की बात कर रहे हो आप? Okay, so I hope it is clear. System boundaries, internal and external. Hello. Yes. Okay. तो आगे बढ़ते हैं. अब यहाँ क्लोज सिस्टम है तो सपोज containing gas. Now this is my system boundary. Let's say these red dotted lines. I hope they are visible. ठीक है. Now here, suppose if I supply the heat to one side of the cylinder, what will happen? You know, this heat will enter in the system. Gas will absorb the heat, and then gas molecules kinetic energy will increase, motion will increase, and then they will become excited and they will want to expand. Okay, so they will move here and there. अब जैसे आप हो, suppose if you have seen गोलमाल सीरीज मूवी, उसमें बहुत सारे ऐसे सीन है और भी कई मूवीज में. अगर आपको किसी हॉट सरफेस पे अगर बिठा दिया जाए, क्या होगा? If they put you on some hot surface, what will happen? Or if they make you sit over a hot surface, you will become excited. You will also start jumping here and there. So in the same way, gas molecules will also do. So these gas molecules in that jumping process will try to move. They will try to push this piston. अब आप एक बंद कमरे में हो, अचानक उसमें सपोज गर्मी बढ़ जाए, स्टीम सप्लाई कर दिया किसी ने, तो what you will do, you will all just to break free, you will also try to break the walls or the door of the room to come out. In the same way, gas molecules will also do the same. They will exert the force. Okay, so in that process, when they will exert the force, they will try to push the piston. So piston will move here, and when piston will move, piston will shift, suppose to a new position. Let's say something like this. So you can understand in this process, the system boundary of the gas will expand, correct? And if system boundary of gas is expanding, increasing, okay, and this shaft we can say is connected to something via this piston is connected to a shaft or something via connecting rods. So work will transfer. Piston is displacing. Displacement means what? Work. Work is क्या होता है? Force into displacement. So here piston is moving. Piston is getting displaced. So that means work will be there. So here what you can observe. What is the meaning of closed system? What you can understand? See, if I talk about the observations, okay, the first observation I can make is heat is heat crosses the system boundaries. Okay, as you can see, heat is crossing the system boundary and then entering in the gas. Now, gas will absorb the heat and start expand. And when gas will start to expand, so in this process, you can understand what will happen. Some or all part, but for now we will write some part of heat will convert it to work. Now you can ask her why some part, why not all the heat? We will see as the course will progress, you will understand. By the way, you guys already know this is a revision series. So you have the idea. Some part of the heat will convert into work. And now piston is moving. The piston is outside the system boundary. So that means work also crosses the system boundary. Now here, what about the mass of the gas? The mass of the gas is a constant. As nothing is coming in, nothing is going out. And last, the most important one, system boundaries are not fixed. You can see system boundaries are changing. So that is what we can say, system boundaries are not fixed. So since mass is constant, system boundaries are not fixed. Okay. So that's why this flow system is also known as non-flow process. If any process occurs on the system, piston and cylinder assembly in a closed system, so that process will be the non-flow process because nothing is going in, nothing is going out except the energy. So this is my closed system. I hope it is clear. Yes, Jagdish. Here we will cover the and all the basic thermodynamics from first basic fundamentals to second law, entropy, and then thermodynamic relations. So if you are from मैकेनिकल इंजीनियरिंग ऑल्सो तो बेसिक थर्मो पार्ट आपका भी रिवाइज हो जाएगा अच्छे से. You will also be able to revise all that. Okay, so this is closed system, guys, but it is a revision series. Okay, but yeah, you are welcome to ask your doubts. No issues. So next is open system. So that's how, guys, we can define the closed systems and similarly open system. So open system, you can remember there are so many examples. Like one example is, if we say, suppose a compressor, one inlet pipe, one outlet pipe, then there is a storage, there is a piston. Piston is connected to shaft via rod, which is shaft, which is there joined by the motor, so that we can supply the electrical energy to use. So you know what happens here in the compressor. Suppose it is there are fins attached to it. You know the fins, what they do? Extended surfaces. The system boundary is, let's say, this. Okay. So you know what will happen here? Air will enter, atmospheric air, or we can say low pressure air. From the motor, we send the electrical energy, which will convert into work, and then piston will move. It will compress the air, and now this high pressure air will enter into the storage. And as per the requirement on petrol pumps or on the shops, vehicles are coming and going. Some vehicles ask for the to fill the air in the tires. Okay, not all. So that's how the uses, the application, or basically we can say air outlet is not यूनिफॉर्म. ठीक है. तो यहाँ पे क्या ऑब्जर्वेशन आप कर सकते हो, क्या अंडरस्टैंडिंग आप कर सकते हो, आप देख सकते हो. ठीक है. फर्स्ट थिंग फर्स्ट, वर्क क्रॉसेस द सिस्टम बाउंड्रीज थ्रू द मोटर. देन सम और ऑल पार्ट ऑफ वर्क विल बी कन्वर्टेड टू हीट. तो हम समी लिख देते हैं इन जनरल. Heat which is getting generated here due to the compression, that will leave the compressor thanks to the fins and other stuff. So we can say heat also crosses the system boundary. And the amount of air, the mass of air in the system, inside the system boundaries is not uniform. That is not constant, you can say. But system boundaries are fixed. So this is what we call flow process. ठीक है. तो इसे आप फ्लो प्रोसेस भी बोल सकते हो. So any process which occur on a open system, because mass is coming in, mass is going out. So that is what we call flow process, and this is what we call open system. I hope it is clear. ठीक है. तो ओपन सिस्टम के कैरेक्टरिस्टिक्स हैं ये. ऑब्जर्वेशंस बोल लो, कैरेक्टरिस्टिक्स बोल लो. आई होप यू आर एबल टू अंडरस्टैंड. ठीक है. अब इसमें आगे बढ़ते हैं तो हमारा आइसोलेटेड सिस्टम आता है. आइसोलेटेड सिस्टम हमारे वो सिस्टम होते हैं इन विच वी हैव द रिजिड सिस्टम बाउंड्रीज. Rigid system boundaries means they will not allow the heat, no heat transfer, no work transfer, no mass transfer. मतलब no energy transfer, no mass transfer. So they are isolated, totally isolated. Like in class also we discussed about the example कि on some day during your BTech if you plan कि यार today we will do the mass bunk in this lecture, ठीक है, पूरी क्लास ने मिलके प्लान बनाया कि yes we will do the mass bunk, but you know then there will be one or two person will come who will go against the entire class. No, we will do the class, we will join the class, you know why? तो आप उन्हें कितना ही ट्राई करो कन्विंस करने का, they will not going gonna convince because they have created a layer, a rigid layer around them. तो आपकी बातें उनके अंदर पहुंच ही नहीं रही हैं because they have make the those people, उन्होंने आप खुद को isolated बना लिया. I hope you are understanding. ठीक है. So this is the basic terminologies about the system. Apart from that, there is a one term known as thermodynamic state. Thermodynamic state means, all the thermodynamic properties of any system at a given time. Suppose for any system, there are so many properties, temperature, pressure, volume, internal energy, enthalpy, etc., etc., etc. So either you can talk about each of those properties or in general you can say the state. ठीक है. अब आप बोलने जाओगे मुझे सारी प्रॉपर्टीज पता है, इट डजंट लुक नाइस, तो इन जनरल हमने बोल दिया आई नो द स्टेट ऑफ द सिस्टम. सिंपल. ओके. एंड when uh, when the thermodynamic state of a system changes, it is said to be undergone a thermodynamic process. Okay. मतलब what is thermodynamic process? Any action because of which state change. That is thermodynamic process. Okay. And I hope you know that thermodynamic processes here we can classify in different cases. We will see later on, not now. Thermodynamic state, thermodynamic process. Now one is thermodynamic cycle. Thermodynamic cycle means thus a sequence of thermodynamic processes that leads to the initial state again. ओके. मतलब मेरे पास बहुत सारी ऐसी थर्मोडायनेमिक प्रोसेसेस हैं जो सीक्वेंस में हो रही हैं और अल्टीमेटली आई एम रीचिंग द फाइनल इनिशियल स्टेट अगेन. जहां से शुरू किया था वापस वहीं आ गए. सो देन वी से थर्मोडायनेमिक साइकिल. एंड हियर यू कैन अंडरस्टैंड फॉर अ थर्मोडायनेमिक साइकिल, a fun fact, for a thermodynamic cycle, minimum how many processes are required? Anyone? Minimum how many processes are required for a thermodynamic cycle to form a thermodynamic cycle? Correct. 2. ओके. अब इसमें आगे बढ़ते हैं तो नेक्स्ट आता है हमारा थर्मोडायनेमिक प्रॉपर्टीज. तो थर्मोडायनेमिक फर्स्ट इज वॉल्यूम डिनोटेड बाय V. You know what is volume? The space occupied by a system in three dimensions. That is volume. And the units, meter cube SI units, and 1 meter cube equal to 10 to the power 3 liter, or you can say 10 to the power 6 centimeter cube. तो यहां से आप ये भी बोल सकते हो 1 ml is equal to 1 cubic centimeter. As you can see, यहाँ से आपका 1 liter equal to 110 to the power 3 cubic centimeter आ जाएगा, which means 1 ml equal to 1 cubic centimeter. This is volume. I hope it is sorted. Next, pressure denoted by P. You know the pressure is force acting per unit normal area. So weird thing is आज FM की क्लास में ही हमने प्रेशर डिस्कस किया इतना डिटेल में. And here we are writing in just a short form like this. And here you know the different units of the pressure. SI unit is Pascal and unit conversion factor like 1 atm is equal to 101,325 Pascal, 1.01325 bar, 101.325 kilopascal, or you can say 760 mm of Hg, 10.3 meter of H2O, or 760 torr. So these are some common units of pressure which we use. अब यहाँ पे जो कॉन्सेप्ट आता है एब्सोल्यूट प्रेशर और बाकी का वो आपको पता ही है. ठीक है. तो थर्मोडायनेमिक प्रेशर अगर आपसे पूछा जाता है तो इसका मतलब एब्सोल्यूट प्रेशर ही आपसे पूछा जा रहा है. लाइक इफ दे मेंशन रेफर एज thermodynamic pressure. So thermodynamic pressure means absolute pressure. And you guys know absolute pressure we defined as summation of plus minus atmospheric pressure plus minus gauge pressure. Okay. इसे सही से अगर लिखें तो आप ऐसे ही बोल सकते हैं. Atmospheric pressure plus gauge pressure, or if gauge pressure is negative, so you can say PATM minus PV, which is the vacuum pressure. You know, negative gauge pressure is also known as vacuum pressure. Correct? Now, third is temperature, denoted by T. What is temperature? So you guys know temperature is a property of system. It can be defined as the property of a system which is responsible to keep it in thermal equilibrium. ठीक है. मतलब फॉर एग्जाम्पल सपोज अगर हमारे पास कोई दो सिस्टम है, लेट्स से वन इज सिस्टम ए which is at 40 degrees Celsius, one is system B which is at 4 degrees Celsius. If they are in contact, if they are in contact, what will happen? You know that if they are in contact, heat transfer will start from high temperature body A to low temperature body B. Okay. And you know, in this universe, every system wants to attain the stability. You are also preparing for GATE and PSUs exams to attain the stability in your life, because you guys think after GATE exam, PSUs, life is set or stable. That is the idea, I believe. That's why you are preparing. Otherwise, क्या जरूरत है? कोई रूल थोड़ी है कि हमें गेट के लिए पढ़ना बीटेक किया है तो. Okay. So this is the whole idea. So here also these two systems, when they are in contact, they will also try to achieve the thermal equilibrium. So which property is responsible for that? Temperature. So इन हीट ट्रांसफर टेम्परेचर आपने ऐसे पढ़ा होगा. हीट ट्रांसफर सब्जेक्ट में टेम्परेचर बोलते हैं. थर्मल पोटेंशियल डिफरेंस कॉजेज हीट ट्रांसफर. यहाँ पे प्रॉपर्टी ऑफ अ सिस्टम कॉजेज थर्मल इक्विलिब्रियम और हेल्प द सिस्टम टू अचीव थर्मल इक्विलिब्रियम. सिंपल. ठीक है. तो यहाँ पे अल्टीमेटली हीट ट्रांसफर विल स्टार्ट एंड द टेम्परेचर ऑफ बॉडी ए, the body which loses the heat, the temperature of that body will decrease. Body B, which gaining the heat, absorbs the heat, its temperature will rise. And ultimately, when the temperature of two bodies will become same, let's say 22, in this case, suppose. So then the heat transfer will become zero. Eventually, the net heat transfer becomes zero. And that is what we call thermal equilibrium. Correct? बट अगर आपको टू बी प्रिसाइज जाना है तो वो हम क्लास में डिस्कस कर चुके हैं. थर्मल इक्विलिब्रियम इज अ डायनेमिक इक्विलिब्रियम प्रोसेस. यू नो, अब उस सब में मैं नहीं जा रहा. अगर कोई डाउट होगा मेंशन कर देना, देन ओनली आई विल एक्सप्लेन. अदरवाइज वी आर मूविंग. इट इज अ डायनेमिक इक्विलिब्रियम. ओके. और टेम्परेचर स्केल की अगर हम बात करें, यहाँ टेम्परेचर यूनिट्स की, तो उसे हम टेम्परेचर डिफरेंट डिफरेंट टेम्परेचर स्केल्स की हेल्प से मेजर कर सकते हैं. Like usually we define the temperature scales at 1 atm with the help of boiling point of water and ice point or freezing point of water. So in degree Celsius scale, if you see, freezing point is 0 degree Celsius decided and boiling point is 100 degree Celsius decided. In degree Fahrenheit, it is 32 degree Fahrenheit. It is 212 degree Fahrenheit boiling point. But these two are the normal temperatures. Okay. But if we talk about the absolute temperature scales, तो एब्सोल्यूट टेम्परेचर स्केल्स हमारे दो हैं. वन इज केल्विन एंड वन इज रेनकाइन. केल्विन स्केल सेज freezing point of water will be 273.15 Kelvin and boiling point will be 373.15 Kelvin. Rankine scale says the freezing point of water at 1 atm will be 491.6 degree Rankine and the boiling point of water will be 671.6 degree Rankine. Okay, so you should remember that these two are the absolute temperature scale. Absolute temperature scale means the lowest possible value is 0. Correct? Now, if you need to find out the relation between these temperature scales from one unit to another unit, how can you do that? So see, very easy. Like if I want to do it for degree Celsius and Fahrenheit, ये सब हम कर चुके हैं तो आपको आइडिया होगा अच्छे से. बट मैं बता रहा हूँ because it is important again. Like if you want to relate degree Celsius and degree Fahrenheit, so just take any random value. Think like this. We have two thermometers, degree Celsius and degree Fahrenheit. Now, dip these two thermometers in a bath. So ultimately, you know, temperature has to be, so the temperature of that bath or the system will be some value. Although in different units it can be different, but ultimately the value, the worth will be same. मतलब अगर मैं आपसे बोलूं 1 मीटर, what is the length of this pen? 1 मीटर. और आपने वो इस मेरे पीछे कोई पर्सन एक्स है, उन्होंने बोला नो 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 100 सेंटीमीटर. आर वी रॉन्ग? आर वी सेइंग एनी डिफरेंट वैल्यूज? नो. 1 meter and 100 centimeter units are different, so magnitude is different, but the worth, the value is same. In the same way, degree Celsius and degree Fahrenheit scale, if I put in the bath, so temperature of that bath will be constant, will be a value, but in different scale, obviously two different readings will come, but eventually, you know, the worth will be same, the value will be the same. So let's say on T degree Celsius, on degree Celsius scale, it is T degree Celsius and degree Fahrenheit scale, it is T degree Fahrenheit. ठीक है, ये वैल्यू हो गई वो. अब क्या करना है? Subtract the freezing point, respective freezing point. So on degree Celsius, it is 0. On Fahrenheit, it is 32. Now divide them by their total difference between the boiling point and freezing point. So here it is 100 minus 0. Here it is 212 minus 32. Correct? So you can see here you will get T degree C equal to T degree F minus 32 whole multiply by 5 upon 9. So that's how you can relate degree Celsius and degree Fahrenheit into each other. Okay. Similarly, if you take Kelvin scale here, so you will get T degree Kelvin equal to T degree Celsius plus 273.15. I hope this is clear. That's how you can find out the things. और उसी के ऊपर न्यूमेरिकल्स भी आते हैं. वो आपसे कहेंगे जी एक डिग्री एन का हमारे पास टेम्परेचर स्केल है, फाइंड आउट द वैल्यू. We are introducing a new temperature scale in degree n, where the freezing point is, let's say, 80, boiling point is, suppose मैं करा ही देता हूँ ना, सोचना क्या है. सपोज आपसे बोला मेरे पास एक टेम्परेचर, नया टेम्परेचर स्केल हमने डिफाइन किया इन डिग्री एन, जिसका फ्रीजिंग पॉइंट, based on that scale, freezing point of water is, let's say, 80 degree, and boiling point of water is, let's say, 250 degree and okay. So they are saying, या उसे एक काम करो 260 ले लो, just for the simplicity, nothing else. Now they are asking 100 degree N is equal to how many degree Celsius. ठीक है, इस तरह के क्वेश्चन आते हैं आपके. तो यहाँ पे क्या करो, डिग्री सेल्सियस स्केल ले लो एंड यू नो द वैल्यूज, या फिर फॉरेनहाइट में भी अगर पूछे तो नो इश्यूज. तो डिग्री सेल्सियस में आपको पता है T डिग्री सेल्सियस माइनस इट्स फ्रीजिंग पॉइंट डिवाइडेड बाय टोटल डिफरेंस इक्वल टू T डिग्री N माइनस इट्स फ्रीजिंग पॉइंट डिवाइडेड बाय टोटल डिफरेंस. तो यहां से आपका T डिग्री सेल्सियस आ जाता है 260 माइनस 80, 180, 100/180, 10/18, 5/9. तो ये आ जाएगा आपका T डिग्री N माइनस 80 होल मल्टीप्लाई बाय 5/9. करेक्ट. तो यहाँ पे वैल्यू रख दो. 100 डिग्री एन पूछा है, डिग्री सेल्सियस में कितना होगा, तो पुट 100 डिग्री एन हियर. तो ये आ जाएगा आपका 20 × 500/9 डिग्री सेल्सियस, whatever, 11.11. You know, that is the answer. That's how you can do it. I hope it is clear. ऐसे अगर फॉरेनहाइट में पूछा होता आप वो भी निकाल सकते थे. सॉर्टेड. अब टेम्परेचर स्केल में एक इंपॉर्टेंट पॉइंट ये होता है जो आपको पता है, फॉर डेल्टा टी, अगर मुझे टेम्परेचर डिफरेंस के लिए चेक करना है, तो यू नो 10 डिग्री सेल्सियस इक्वल टू 283.15 Kelvin and 11 डिग्री सेल्सियस इक्वल टू 284.15 Kelvin. तो आप चेक कर सकते हो. वन डिग्री सी इक्वल टू 1 डिग्री केल्विन आ गया. ठीक है, तो ये याद रखना, डेल्टा टी के लिए 1 डिग्री सी और 1 डिग्री केल्विन हमेशा इक्वल होते हैं. यूनिट्स, जैसे स्पेसिफिक हीट की अगर आपको यूनिट निकालनी है, डिफाइन करना है, तो वहां पे हेल्प हो जाती है. ठीक है, मतलब जैसे अगर आपसे कहें जी सीपी ऑफ वाटर इज 4.2 जूल पर केजी, किलो जूल पर केजी पर केल्विन, और आपसे पूछें ये वैल्यू क्या होगी इन किलो जूल पर केजी पर डिग्री सेल्सियस, तो इट विल बी सेम, because this is delta T, and for delta T 1 डिग्री Kelvin and 1 डिग्री Celsius are equal. ठीक है. बट अगर आपसे कहा जाए भाई 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 what will be this value in kilojoule per kg per degree Fahrenheit, अब बताओ. This is for you guys, giving you 1 minute. Cp is 4.2 kilojoule per kg per Kelvin. Convert this value in kilojoule per kg per degree Fahrenheit. हाँ जी. Any answer? और मेरे शेरों, बताओ भाई. Is NIT tag is really matters in life? It is about the perspective. Basically your bank balance. आज की डेट में लोगों, majority of the people think you are successful if you have the bank balance. If you have money in your account, then tag is not important. Although I don't believe in this philosophy completely, but this is the fact of this modern age, 2.625. ओके, आओ देखते हैं. ठीक है गाइस. तो फॉर डेल्टा टी 1 डिग्री सेल्सियस इज इक्वल टू हाउ मेनी डिग्री फ़ारेनहाइट. अगर आपको ये पता है तो आप ये सॉल्व कर लोगे. तो यहाँ पे आप देखो, 10 डिग्री सेल्सियस इक्वल टू हाउ मेनी फ़ारेनहाइट, यू कैन कैलकुलेट. T डिग्री सी इक्वल टू T डिग्री F माइनस 32 होल मल्टीप्लाई बाय 5/9. तो यहाँ से आप इसे T डिग्री F में कन्वर्ट कर सकते हो. तो 10 डिग्री सेल्सियस इज इक्वल टू हाउ मेनी फ़ारेनहाइट. 10 × 9 डिवाइडेड बाय 5 प्लस 32. तो ये आ गया मेरा 50 डिग्री फ़ारेनहाइट. Similarly, the 11 you can see it is 51.8 degree Fahrenheit. So you can see that for delta T, 1 degree Celsius equal to 1.8 degree Fahrenheit. Okay. तो हमारी वैल्यू क्या थी भाई? हमारी वैल्यू थी CPW इज इक्वल टू 4.2 किलो जूल पर kg पर डिग्री सेल्सियस. एंड यू नो दैट 1 डिग्री सेल्सियस इक्वल टू 1.8 डिग्री Fahrenheit. तो यहां से आपका CP ऑफ W आ जाएगा, क्या आ रहा है? 4.2 divided by 1.8, that is 2.33 kilojoule per kg per degree Fahrenheit. This is the answer. नितेश, क्या कर दिया आपने? ये 0.3 कहां से बढ़ा दिया आपने? 0.3? नो, this is 2.33333. Yes, that's the correct answer. That's how you can do the unit conversion. See, I hope it is clear. So this is something about the temperature. ठीक है, अब आगे बढ़ते हैं. अब थर्मोडायनेमिक प्रोसेसेस की बात हो रही है, तो यहाँ पे एक नेक्स्ट आता है आपका सबसे पहले क्वेसी स्टैटिक प्रोसेस. क्वेसी स्टैटिक प्रोसेस क्या होता है? इट इज extremely slow process such that every step change in the process is in equilibrium with the previous step. Okay, this is one hypothetical imaginary process. Hypothetical concept. अब ये क्या होता है, तो आप लोगों को अगर याद हो तो हमने एक एग्जाम्पल लिया था पिस्टन एंड सिलेंडर असेंबली का. Suppose here we have a gas in a piston. This is my system boundary. Piston and cylinder assembly, I have some gas, and this is the system boundary. Okay. Here, Suppose this piston, this system is there. Now you know gas will exert some pressure on the system. 1.6 ले लिया. अरे, gas will exert some force on the piston, pressure on the piston. So to compensate that force and piston, हम यहाँ पे क्या करेंगे? We will put some extra weight on from the outside to balance the pressure force exerted by the gas. ठीक है? तो यहाँ पे हमने क्या किया? Suppose हमने small small dust particles रख दिए, n number of dust particles. You know, dust particles are very small in nature, very lightweight particles, almost like zero. So such infinite or n number of particles we have placed over the piston to balance the force exerted by the gas. So in that process, you know, when the force balance is there, this piston will be in mechanical equilibrium. Mechanical equilibrium means pressure force exerted by the gas will be equal to the total force and weight of the piston acting on the gas. Correct? Now here, in the second scenario, suppose instead of dust particle, हमने dead weights रख दिए to manage the force balance. ठीक है? Now understand this. Here, if I remove one weight, what will happen? If I remove one weight here, so you know, mechanical equilibrium will disturb and piston will rise. Piston will rise very rapidly, or I can say rapid expansion or movement of the piston. Correct? Piston बहुत ही तेजी से भागेगा भाई. And when piston will move very fast, so you know what will happen? Friction will occur. Friction will come in the picture. ना आप ऐसे ही देख लो ना. You have your mobile phone, the screen or the mirror in your bedroom or bathroom. Just move your dry finger. Make your finger completely dry and move over the glass surface, mirror surface very fast. So when you move your finger very fast, you will feel little heat, the friction. But if you move your finger very slowly, you will not feel any heat or friction. Correct? So यहाँ पे, this is what we call irreversible process. So in thermodynamics, any process in which friction is involved, rapid movement is involved, that is what we call irreversible process. On the other hand, if you look at this example, here suppose I remove one dust particle. ठीक है? जब मैंने यहां से एक डस्ट पार्टिकल रिमूव किया तो क्या होगा? You know, force balance equilibrium will disturb. So piston shall move upward. But you know, the weight of dust particle is so small that piston will move very slowly. And if piston is moving very slowly and hardly any deviation is there. Okay. So in that case, you know, we can neglect such a small deviation like dx tends to 0. ये जो डेविएशन है क्या है? सपोज पिस्टन यहाँ था, वो पिस्टन हमारा यहाँ आ गया. This is my new piston. So you can see the deviation is this dx, which is very small. So we can neglect it. So that's how if you remove dust particle one by one, one by one, so you know piston will move slowly, very slowly. So in such a slow process that it will not feel any friction. It is kind of a frictionless. And in thermodynamics, all the frictionless processes are reversible processes, you know. And here, the movement of piston is very slow. And it is a reversible process. So it is what we call quasi-static process. because you can understand this deviation we can neglect, which is taking place. Such a slow deviation with every step. So that's why it is what we call quasi-static. अब यहाँ पे जो best part है पता है क्या है? The best part is you can easily say that all quasi-static processes, this is a fun fact, are reversible. And all reversible processes are quasi-static. Tell me which one is correct. Statement 1 or 2? Tell me. इससे क्या हुआ? हाँ जी guys, बोलो. Which is the correct statement? Correct. Absolutely. ये हम बात कर चुके हैं. All reversible processes are quasi-static. That is true. We have discussed that. But all quasi-static processes are not reversible क्योंकि in a quasi-static process, every step is in equilibrium with the previous one. But still, if friction may occur, then it will not be your what we call quasi-static. Okay. I hope it is clear. अब यहाँ पे बेस्ट पार्ट क्या है देखो अब एक चीज तो हम डिस्कस करना रहेगा तो हमने प्रॉपर्टी डिस्कस कर ली अब उनके आगे बढ़ते हैं उनका ग्राफिकल रिप्रेजेंटेशन सो यू शुड नो दैट फर्स्ट थिंग फर्स्ट to define the state of any system, to define the thermodynamic state of a system, we need minimum of two properties. Okay. And two properties like suppose those two could be temperature pressure or pressure volume or volume temperature. तो इन प्रॉपर्टीज की हेल्प से अगर आप देखो टेम्परेचर प्रेशर प्रेशर वॉल्यूम वॉल्यूम टेम्परेचर एंड इफ यू वांट टू ड्रॉ अ ग्राफ तो ऑन अ कार्टेशियन सिस्टम यू कैन अंडरस्टैंड we can draw n number of graphs, n number of permutation combination are possible, like you can draw between temperature pressure or pressure temperature, you can draw between pressure volume or volume and pressure, you can draw between volume temperature or temperature and volume. Correct. N number of graphs you can draw, but generally in thermodynamics we prefer this one, PV diagram. Okay, we use all other also, but mainly we talk about the PV diagram because other graphs don't have any significance as such. Wo other graphs, other variations we can use depending on the application or the process. Okay, but mainly we talk about the PV diagrams. Why? Because they have the significance. What is the significance? See, if I talk about a PV diagram, pressure and volume diagram, okay, let's say there is a graph, something like this, between the two states, 1 and 2. So, you know, what is work done? Mathematically, we can write work done as force into displacement, correct? For gases, like here, if I ask you, based on this example, how much force this gas was exerting? So that was the pressure force. And pressure force is Fp, which you can write as pressure into cross-sectional area. And how much displacement was there? Dx. You know, we have seen dx displacement was there. Correct. So cross-sectional area into dx can be written as dv. Can you see? This is the significance I was talking about. Means for PV diagram, if you see the area under the curve, from 1 to 2, that represents the total work done. For a PV diagram, area under the curve represents the work done. Okay, I hope it is clear. So that's why we prefer PV diagram. Now question है PV diagram बनता कैसे है, क्यों बनता है? अरे भाई देखो, कोई ऐसी स्टैटिक प्रोसेस की अगर मैं बात करूं, जैसे ये है, suppose this was my initial state 1 and I want to reach here at the final state 2. Now think, see this. When you remove the first dust particle, a slight deviation will occur. State will change. Let's say it will move to somewhere on this side. एक काम करता हूँ मैं इसे दोबारा बनाता हूँ और अच्छे से बड़ा करके ताकि आपको क्लैरिटी मिले. So when you remove the first particle, so deviation will come. Gas will expand, pressure will piston will move upward, so pressure has to decrease logically. Volume has to increase. So this point, next point will come below this. Correct. But the deviation is so small that we cannot make this point very away from the previous step, previous state. Now, when you remove the second dust particle, again the deviation was so small we can neglect that. So it was in equilibrium with the previous one. So these two will be in contact. Now, on the removal of third particle, and then fourth particle, and then fifth particle, and then sixth particle, seventh, eighth, ninth, and so on. When you will keep on removing all those particles one by one, so deviation will be so small that each and every particle, each and every state will be in equilibrium with the previous one. And all these points will be interconnected. Okay, means if you connect these points, you will be able to draw a graph like this. Okay. So this type of graphs we can draw only for quasi-static or you can say reversible processes. And we draw them with the help of solid line or solid curve, you can say. This one. Okay. But on the other hand, if you look for the second scenario, the irreversible process, so you remove the dead weight, piston will move very rapidly And if piston will move rapidly, so you know the deviation will be very small, very fast. Very large deviation will come. सीधा वो state 1 से state 2 पे आ गया. Such a large deviation, no contact between them, no equilibrium with the previous step. So for irreversible process, such graphs we represent by dotted line. And for these processes, since you are not able to draw the graph, so here you cannot use this relation. Work done is equal to integration of PdV. This is not used. Remember this. This relation we use only for reversible processes or quasi-static processes. Depreciation, elimination approach and proportionate adjustment method. थैंक यू नैतिक, हमें इकोनॉमिक्स का ज्ञान देने के लिए थर्मो की क्लास में. वेरी वेरी थैंक यू. We will definitely learn these two methods. Guys, as Naitik suggested, these two are very important methods. So please do prepare these two topics also. So I hope it is clear about the reversible and irreversible process, quasi-static process and PV diagram. That for reversible we can draw like this, and for irreversible it will be a dotted line. We cannot represent them. And here we cannot calculate the work done like this. Are we clear with this, everyone? Yes. Okay, wonderful. ठीक है. तो आज ऑलरेडी 1 घंटा हो गया भाई, हमें क्या बात है. चलो फिर इस सेशन को हम यहीं रैप अप करते हैं, एक लास्ट डिस्कशन करके डायग्राम में, बस जो हमने पॉइंट्स डिस्कस किए थे एक बार उन्हें. सपोज इफ आई टॉक अबाउट अ पीवी डायग्राम, लेट्स से इट इज समथिंग लाइक दिस. So on this PV diagram, these vertices, or you can say the points 1, 2, and 3, they represent the thermodynamic state. Okay, like state 1, state 2, state 3. If you talk about the lines like 1 to 2, 2 to 3, or 3 to 1, these represents thermodynamic process. The connectivity between the two state is thermodynamic process. Okay, and if you see, if you write like this, if you uh, uh, include, if you compile entire graph, something like 1 to 2, 2 to 3, 3 to 1, then it represents thermodynamic cycle. Okay, so the question is, how we will represent thermodynamic cycle? So we will represent thermodynamic cycle as 1 2 3 1. मतलब 1 से शुरू हुआ, 2 पे गए, 2 से 3 पे गए, 3 से वापस 1 पे आ गए. This is thermodynamic cycle 1 2 3 1. Thermodynamic process. What is the thermodynamic process here? 1 to 2, 2 to 3, and 3 to 1. These are the individual thermodynamic processes. 3 thermodynamic processes are there, and 3 states are there. 1 2 3. Correct. So that's how we interpret. We read the PV diagram. Basically, the points and geometry. Okay. Now, which process there will be and all that we will see next time. तो यहाँ तक हमारे बेसिक फंडामेंटल्स आई थिंक कवर हो गए हैं गाइस. ठीक है. अब यहाँ पे दो चीजें डिस्कशन के लिए बचती हैं. हीट एंड वर्क, उनकी भी बात कर लेते हैं. So, heat and work both are the boundary phenomena. You know what is heat, what is work. I'm not going in that detail. Both are the boundary phenomena. Both are the transient phenomena. But what boundary phenomena means, we will talk about the heat, we will talk about the work only and only when they will cross the system boundary. Boundary phenomena means when they crosses the system boundary, only then we can talk about them. Otherwise not true. ठीक है? अब मैं जैसे आपसे बात करूं, सपोज ये एक रूम है, इस रूम के एक कॉर्नर में यहाँ पे सपोज कोई सूटकेस रखा है. Okay, this is point one. Can you, if I ask, what is work here? What is work? What is work? Can you answer? No. Now if I give you a task कि यार इस बॉक्स को ना यहाँ पॉइंट टू पे ले जाके रख दो, तो आपने उठाया बॉक्स या जो भी किया, आपने यहाँ टू पे ले जाके रख दिया. अब यहाँ पे पूछो फाइनल स्टेट में व्हाट इज वर्क, व्हाट इज वर्क, व्हाट इज वर्क. कैन यू आंसर? नो. कितनी मेहनत लगी, क्या हुआ, कुछ नहीं बता सकते. करेक्ट. बट इफ आई से ड्यूरिंग द प्रोसेस means when you were transferring the box from 1 to 2 at that time, what is the work? Then you can answer, yes, I did some work, sir. I can feel it. Okay. And now you can understand one more thing here. When I talk about the work done, here you can do this task in three ways, many ways, but I'm talking about the three, for example. Like first is, suppose method A. Method A is you carry the box with you. You lift the box, carry it along with you, and put it on the ground at point two. Method B was you throw the box. At point one, you pick up the box and you throw towards the point two. Correct? And method C was, suppose you drag the box over the ground. It was heavy. Suppose it was heavy and you were not in a mood to do any extra hard work or to give any pressure to your back. So what you did, you just drag the force over the ground. Correct? So these are the three different ways by which you transport the box from 1 to 2. Now, in these three different ways, if I ask you the efforts made by you, the work done by you, the energy consumed by you to do this task, is it same or different? Is it same or different? अब ऐसे ही सोच लो, जब आपने ड्रैग किया तो फ्रिक्शन फोर्स भी पिक्चर में आ गया होगा. थ्रो किया तो एयर का तो कोई फ्रिक्शन था नहीं है सच. ओनली सम स्मॉल ड्रैग और लिफ्ट फोर्सेस आर देयर which you can count or neglect as well. Okay. So in all the three methods, here suppose work done was WC, here WA, here WB. So you can understand WA is not equal to WB and that is not equal to WC. Okay. So in different methods, in different ways, we did a different type of work. So that is what I can say. The work done is a path function because it depends on the process, on the path we are using. Similarly, the heat will also be a path function. How? Because, for example, suppose if I say, hey, buddy, I have two containers. Suppose here we have some gas in these two containers. First container A, I have maintained at constant pressure. Second container B, I have maintained at constant volume. Initial temperature in both the cases was same. Let's say 25 degrees Celsius. Now let's say I want to reach to a final temperature 50 degrees Celsius in both the scenarios. So the amount of heat supply by you in process A under constant pressure and in process B, container B under constant volume will be same or different. We will see later on, but you guys already have the idea that this heat transfer for the same delta T will be different. Correct? So that means heat transfer is also a path function because it depends on the process we are using. So these are the three things you know. And next, if I talk about the fundamental unit, the fundamental unit for heat transfer is calorie, and for work done, it is joule. ठीक है. अब आप बोलोगे सर इसका क्या मीनिंग है? अरे भाई हीट भी तो हम जूल में लिख लेते हैं. हाँ लिख लेते हो, but that is not the fundamental unit. Why? Because joule, what is 1 joule? So you will define 1 joule as the work done on a subsystem to displace it by 1 meter when 1 Newton force is acting. That is 1 joule. What is 1 calorie? 1 calorie is the heat amount of heat required to increase the temperature of 1 gram of water by 1 degree Celsius. यही बोलते हो ना? 1 calorie is the heat required to increase the temperature of 1 gram of water by 1 degree Celsius at constant pressure. Correct. That's why we say Cp of water is 1 calorie per gram per Kelvin or degree Celsius. Similarly, if I ask you, and what is 1 calorie? You know 1 calorie equal to 4.1868 joule. So this will be the unit in joule. That is the value you use. And similarly, if I talk about 1 joule, so 1 joule is the work done when 1 Newton force act on a system to displace it by 1 meter in the direction of force. So you can see in the definitions, when I'm talking about the calorie, heat is coming. So it is fundamental unit. But when I'm talking about the joule, so here you can see work is coming. So joule is the fundamental unit of work. Although unit, thanks to unit conversion, we can do all these things. आपने टीवी का एग्जाम्पल यहाँ पे सूटकेस का दे दिया. करेक्ट. ठीक है. तो हीट ऑफ वर्क की बात हम तभी कर सकते हैं व्हेन दे विल क्रॉस द बाउंड्री. ठीक है. अगर अभी भी कोई डाउट है तो आप इसे ऐसे समझ लो. कहाँ गया हीट 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 यहाँ पे. एक और एग्जांपल ले लेते हैं. सपोज आई से देयर इज वन ऑब्जेक्ट ए. कैन यू टेल मी व्हाट इज हीट? कैन यू टेल मी व्हाट इज हीट? नो. ठीक है. नाउ if I bring this object in contact with another object which is at B, which is at 4 degrees Celsius, then now can you tell about the heat? Yes, because you know temperature difference is there, so heat transfer will occur. So I hope you have understood that heat will come in the picture only when it will cross the boundary. Okay, and this is what I have written. Heat and work are boundary phenomena. They are the transient phenomena, means when they are in journey. During the process, only we will talk about them. But we will not talk about heat and work based on the initial or final state. We will talk about them only based on the path process during the process they are going on. Okay? So these are the few things about the heat and work, guys. I hope they are also clear. Okay? तो आज हमने अपना रिवीजन सेशन में बेसिक फंडामेंटल्स कंप्लीट कर लिए सब. टुमारो वी विल बी टॉकिंग अबाउट द फर्स्ट लॉ इन सेकंड सेशन. ठीक है, उसका लिंक मैं आपको शेयर कर दूंगा ग्रुप्स पर, देख लेना. सेकंड सेशन अगर पॉसिबल हुआ तो हम यूट्यूब पे ही लेंगे, अदरवाइज फिर अनअकैडमी स्पेशल पे लेंगे अगर यूट्यूब पे नहीं हो पाया तो. ठीक है, जैसे मैंने स्टार्टिंग में बोला था, हम ट्राई करेंगे 4 से 5 सेशंस में पूरा बेसिक थर्मो हम अपना रिवीजन कर लें along with some good quality practice questions and PYQs, some of the PYQs. Okay, so tomorrow in the second session I am going to talk about the first law of thermodynamics for closed systems, for open systems and their applications. ठीक है, so tomorrow lecture is going to be very important because every year you will find at least one question from this topic. One question is almost confirmed. Okay, so this is something about the today's session, fundamental, and tomorrow session this. So till tomorrow evening, I will share the link with you. Timing will be the same, 9 p.m. Okay, either we will do it on YouTube or otherwise, if it will not be possible due to some reason, so we will do this second session on Unacademy Special. ठीक है, वैसे भी मैंने स्टार्टिंग में ही आप लोगों को डिस्कस कर दिया था कि कहाँ गया. 2 session we will do on YouTube and 3 on the Unacademy Special. Okay, timing will be same. 1.5 hour to 2 hour के सेशन होंगे, ज्यादा बड़े नहीं रखेंगे, 9 p.m. onwards. ठीक है, बाकी that's all for the day, guys. Thank you. If you have any doubt, any question, then you can ask. You can discuss in the chat. How to enroll for your session? For this session, just contact me on the WhatsApp. Okay. This is my WhatsApp number. Here you can contact, or otherwise, you can join in the Telegram channel. There you will go get the links for each sessions. Okay. So that's all for the day, guys. If you have any other doubt, you can ask any question. I will like to answer. ठीक है, नहीं है? Okay, welcome. So that's all for the day. Or otherwise, you can search Telegram channel on open Telegram app. Search Gate with Ace. You will get my Telegram channel. You can join. Otherwise, the link you can find in the description also. Okay. And I will also try to provide the PDF, this PDF in the Telegram channel as well. Okay. So that's all for the day, guys. See you in the next class tomorrow. Till then, bye bye. Take care. And first law of thermodynamics we are going to revise tomorrow. So be ready. It is gonna be one fun and entertaining session. ठीक है, बाकी जाने से पहले एक बार मैं फिर से आपको याद दिला रहा हूँ कि अनअकैडमी पे ऑफर चल रहा है, जिसमें 8,999 9,999 में 9 मंथ्स एंड 12 मंथ्स के सब्सक्रिप्शन ले सकते हैं आपके फ्रेंड्स, कलीग्स, जूनियर, सीनियर. जो ऑफर कल एंड हो जाएगा, they can use my educator code ACE009 to help them so that they can prepare with the quality team, with the most experienced team of chemical engineering in GATE and PSUs field. Me and Uncle, we are the oldest people with a combined experience of more than 27 years. Okay, so milte hain guys kal. Till then, bye bye, take care. Have a great day ahead. Sayonara.